Hello everyone, myself Sai Prasad, a lecturer in the Ahmedabad High School and the Junior College. Welcome to the series of the lectures of Intermediate First Year Maths A. We have been discussing different concepts of the basic trigonometric ratios and few identities, right. In the last class we have discussed the different angles of ratios, right. For example, we have found out sine 220 like that. Today we will discuss few problems of finding different values of different ratios. Let us do such problems, right. Shall we start? Let us see here. The first question given it is, if sin theta is equal to 4 by 5, right, given that sin theta is equal to 4 by 5, he is clearly telling that theta does not lie in the first quadrant, right. See here, the sine value is positive here. We all know that sine is always positive in the first and the second quadrant, right. He is telling that theta does not lie in the first quadrant, then in which quadrant it may lie? See here, once again, see here, Q1, Q2, Q3, Q4. इसमें here all angles are positive, all ratios are positive. Here sine is positive, here tan is positive, here cos is positive, right. See here, sine is positive here, right. He is clearly telling that theta does not lie in the first quadrant. Then which quadrant the sine is positive? The sine is positive in the first and second quadrant. He is telling that it does not lie in the first quadrant. Then theta lie in which quadrant? Theta belongs to second quadrant, right. Let it be like that. Now let us find the value of cos theta. If sin theta is given, how to find cos theta? I know that cos square theta plus sin square theta is equal to 1. From there I can write cos theta is equal to under root of 1 minus sin square theta, which is under root of 1 minus sin square, that is 4 by 5, 16 by 25, which is under root 25 minus 16 is 9 by 25, which is nothing but 3 by 5. Is it right? This is the value of cos theta. Is it clear? Then he is clearly telling that theta belongs to second quadrant. What is its significance? That the theta has to be in second quadrant. Why? Because cos is negative in second quadrant. We have to specify it. Since theta belong to second quadrant, cos theta is equal to minus 3 by 5. Can you remember this? Is it clear? See here, he gave the value of sin theta. He clearly mentioned that theta does not lie in the first quadrant. Then in which quadrant the sin theta will be positive? It will be positive in the second quadrant. That is why it is very clearly written that theta belongs to second quadrant, right. Then he is asking us to find the value of cos theta. We know the identity that cos square theta plus sin square theta is equal to 1, from which we could find out the value of cos theta, right. Since it lies in the second quadrant, the cos theta has to be negative, right. Let us move on to the next problem, that is secant theta plus tan theta is given as 2 by 3. He is asking us to find sin theta. See here, remember, whenever you find the addition of two things, remember that it will be either in secant or in the cosecant. See here, why it is fixed? Because we know the identity that secant square minus tan square is always 1, isn't it? Let us see that. We know that secant square theta minus tan square theta is equal to 1. This is in the form of a square minus b square, right. Let us split it into a plus b into a minus b. It becomes secant plus tan theta into secant theta minus tan theta, that is equal to 1. What is secant theta plus tan theta? It is nothing but 2 by 3. 2 by 3 into, this will be as it is, secant theta minus tan theta, that is equal to 1. From that we can write it as secant theta minus tan theta is equal to 3 by 2, right. Now let us add this and this. Secant theta plus tan theta is 2 by 3, secant theta minus tan theta is 3 by 2. Why to add? If we add, this tan and this tan will get cancelled. See here, if we add those both, it becomes is equal to 2 by 3. This and this both get cancelled, right. Secant plus secant is 2 secant theta is equal to 3 by 2 plus 2 by 3. Here the LCM is 6, 3 3s are 9, 2 2s are 4. Here it is 2 secant theta. From this secant theta is equal to 9 plus 4 is nothing but 13, 6 2s are 12. This is what we got the value of secant theta, right. See here, he is telling that determine the quadrant in which the theta lies. Secant is positive, in which quadrant does it lie? Secant, if secant is positive, it lies in either in the first quadrant or in the fourth quadrant, right. Therefore, theta belong to quadrant 1 and quadrant 4, right, and he is asking us to find the value of sin theta. How to find the value of sin theta from secant? Again we can do it in various forms. We have did using identity, right. Here let us do by using a triangle which we used to do in our 10th class, right. See here, secant is, for example, if this is theta, what is secant theta? Secant theta is nothing but, what is it? It is hypotenuse by adjacent, right. What is the value of hypotenuse here? 13 into some constant k. What is the value of adjacent here? 12 into some constant k. Let us substitute it here. See here, if this is theta, what about the hypotenuse? This is 13. What about the adjacent? And this is 12k. What about this opposite side? From the Pythagorean theorem, we know that opposite square plus adjacent square is equal to hypotenuse square. From this, we will write it as opposite square is equal to hypotenuse square minus adjacent square. What is hypotenuse square? 13k square, which is 169 minus 144. 169k square minus 144k square, which is nothing but 25k square, that is opposite is 5k. Here it is 5k. Is it right? This is how we will find the value of opposite and everything. From this, can we write directly the value of sin theta? Now, what is the value of sin theta here? Sin theta is nothing but opposite by hypotenuse. What is opposite here for this angle? 5k by, what is hypotenuse here? 13k, right. K get cancelled, we will get sin theta is equal to 5 by 13. Then it is clearly mentioned that theta belongs to quadrant 1 and 4. If theta belongs to quadrant 4, the sin theta value will be negative if theta belongs to quadrant 4. Is it clear? This is how we will solve the value of different kind of thing when the relationship between two ratios are given, right. Now, let us find a different kind of thing. He is asking us to prove this. Tan theta plus cot theta whole square is equal to secant square theta plus cosecant square theta, that is equal to secant square theta into cosecant square theta. Before doing this, let me tell you one thing is, whenever you do such kind of problems, remember that you have to convert everything in terms of sine and cos, right, which is simple to simplify so that you can understand such things. Okay. Shall we do that? Let us do. See here, let us do directly a plus b whole square. What is tan theta plus cot theta whole square? That is a square plus b square plus 2ab. Okay. See here, tan square plus cot square plus 2 tan into cot. Let it be like that. Let us write, can we write from secant square minus tan square can be written as secant square theta minus 1. Cosecant square theta can be written as cosecant square theta minus 1 plus 2 into tan theta. Cot theta can be written as 1 by tan theta. This tan and this tan get cancelled. Then it becomes secant square theta plus cosecant square theta minus 1 that becomes minus 2 plus 2 to get cancelled. Then we will get it as secant square theta plus cosecant square theta. Can you understand here? See here, this is a plus b whole square. I have written it as a square plus b square plus 2ab, that is tan square plus cot square plus 2 tan cot, right. I have written tan square as secant square minus 1, cot square as cosecant square minus 1. Again tan is as it is, cot can be written as 1 by tan. Here tan get cancelled. Here secant square plus cosecant square I have written to one side, minus 1 it becomes minus 2. Already there is plus 2, they both get cancelled and we got this second proof, I mean the first proof, that is secant square plus cosecant square. How to find this? Just convert them into sine and cos. We will see how to get. See here, secant square theta can be written as 1 by cos square, right? Cosecant square can be written as 1 by sine square. If we take LCM cos and sine, we will get it as cos square theta into sine square theta. Let us cross multiply, I mean let us take LCM. Here it becomes sine square, here it becomes cos square theta. Sine square plus cos square is nothing but 1 by cos square theta into sine square theta. 1 by cos square is secant square, 1 by sine square is cosecant square theta. This is how we will prove few problems of trigonometry, right? Let us see. Let us see more problems on this. Okay, let us start. Okay, see here, the question given is if 3 sin theta plus 4 cos theta is equal to 5, they are asking us to find the value of 4 sin theta minus 3 cos theta, right? How to solve this? In the last problem, which we have seen that secant theta plus tan theta value is given, right? In that value, we had a relationship between secant and tan as a negative sign, that is secant square minus tan square. Then we could directly find that value. The relationship between sine and cos, what is there? It is a square plus b square, that is we can't do that, right? Which means we can't further simplify it. That is why let us assume this finding value, that is let 4 sin theta minus 3 cos theta is equal to a, right? Let us take it as 1. What is given? 3 sin theta plus 4 cos theta is equal to 5. Now let us square and add these both things, that is 1 square plus 2 square. What we will get? Let us see now. What is 1 square? That is 4 sin theta minus 3 cos theta whole square plus what is second one? 3 sin theta plus 4 cos theta whole square, that is equal to right hand side, here it is a square and here it is 5 square. Is it clear? Now let us simplify it. Here it is in the form of a minus b whole square, right? Now let us do that. A minus b whole square, that is 4 sin square, that is 16 sin square theta plus 3 cos square, that is 9 cos square theta minus, here it is a minus b whole square, that is minus 2 into 4 into 3, 2 4s are 8, 8 3s are 24 sin theta into cos theta. Again check the second term, a plus b whole square, it is a square, that is 9 sin square plus 4 cos square, which is nothing but 16 cos square minus, is it minus? It is plus, plus 2 into 3 into 4, 2 3s are 6, 6 4s are 24 sin theta cos theta, that is equal to a square plus 25. If you observe here, these both will get cancelled, right? 16 plus 9 sin square, how much is it? 25 sin square plus here 25 cos square is equal to a square plus 25. If we take 25 as common here, it becomes sin square plus cos square, which is nothing but 1, 25 into 1 equal to 25. If we send this that side, it becomes a square is equal to 0, which is nothing but a is equal to 0. Therefore, what is given here? 4 sin theta minus 3 cos theta is 0. This is the value of given question, right? This is how we will solve different kind of problems. Let us go to next thing. So here the question given here, it is cos theta plus sin theta equal to root 2 cos theta. Again he is asking us to find the value of cos theta minus sin theta, which is similar to the last problem. I am already telling, since tan and secant have the relationship with negative sign, we can directly find it out. But sin and cos, we do not have such kind of relation, right? That is why we will take it as, how to do? Let us transform this cos theta to this side, or else let us transform this cos theta to that side. It is better, let us keep this sign this side only. Let us transform this cos theta to that side. It becomes 2 cos theta, root 2 cos theta minus cos theta, where sin theta is equal to, if I take cos theta as common, here root 2 is left, here minus 1 is left. Now We already told wherever we find this root 2, we always try to rationalize or will try to remove it. See here, it is root 2 minus 1. Let us multiply root 2 plus 1 on both sides. Shall we do? Now see here, it becomes root 2 plus 1 into sine theta, that is equal to cos theta into root 2 minus 1 into root 2 plus 1, isn't it? Now see here, this root 2 plus 1 will be as it is, then root 2 minus 1 into root 2 plus 1, what it will become? A plus b into a minus b, that is a square minus b square, root 2 square is 2 minus 1. Is it clear? 2 minus 1 is nothing but 2. Now let us multiply this root 2 to this side, it becomes root 2 sine theta plus sine theta, right. What is the question given? The question given, it is cos theta minus sine theta. If I transform this side, what it will become? If I transform this sine theta, it will become minus sine theta. What is left out here? Root 2 sine theta. Is it clear? This is how they are asking us to prove. Is it clear? These are simple problems, for they may ask you for 2 marks thing. Okay, this is how we will solve different problems. Is it okay? Let us do few more problems. Okay, the next problem here, it is given that tan theta plus secant theta is equal to m, tan theta minus secant theta is equal to n. He is asking us to show m square minus m square is equal to 4 root mn. Okay, let us do how to solve that. See here, solution. He is asking us to find the value of m square minus n square, that is m square minus n square can be written as, see here, this is in the form of a square minus b square, that can be written as a plus b into a minus b. What is m plus n? Let us add these both, that is tan theta plus sine theta plus what is n? Tan theta minus sine theta. The next is m minus n. What is m here? Tan theta plus sine theta minus what is n? Tan minus sine, which is minus tan theta plus sine theta. Is it clear? If we multiply minus to this, it will become minus tan theta plus sine theta, minus will be multiplied to that. Now check what are the things which are cancelling here. Sine theta will get cancelled, right. Here tan theta will get cancelled. Tan into tan, what is it? Tan plus tan, what is it? 2 tan theta into sine plus sine, which is nothing but 2 sine theta, which is nothing but 2 into 2 is 4 tan theta into sine theta. Is it clear? Now let us simplify this, or let us take this RHS. Here it is LHS. Now let us take RHS, that is 4 root mn. Let us check whether we are getting the same thing or not. That is 4 under root, what is m here? Tan theta plus sine theta into what is n? Tan theta minus sine theta. Is it clear? Again this is in the form of a plus b into a minus b. Is it? 4 into a square, that is tan square, minus b square, which is sine square theta. Is it right? This is how we will simplify it. Now see here, let us simplify it more. We can convert everything into single terms, or let us simplify each and every term. Let us convert this tan theta, it will become sine square. Let us take this sine square theta as common. What it will become? Sine square theta into 1 by cos square theta minus 1, isn't it? Let us take this sine outside. What it will become? If we take sine outside, it will become sine theta. Inside it will become 1 minus cos square theta by cos square theta, right. What is 1 minus cos square? Which is nothing but sine square theta. The denominator is cos square theta. What is sine square by cos square? Which is nothing but our tan theta, that is under root tan square theta, which is nothing but 4 sine theta into under root tan square theta is nothing but tan theta. This is the first and this is secant. From 1 and 2 we can prove that m square minus n square is equal to 4 root mn. Therefore, LHS is equal to RHS, hence proved. Is it clear? This is how we will solve different kinds of problems and proofs. Let us solve with few more proving problems in our trigonometry. See here, as of now question given here, it is tan theta plus secant theta minus 1 by tan theta plus minus secant theta plus 1 is equal to, he is asking us to prove 1 plus cos theta by secant theta, right. Now, I already told, whenever we find 1 in terms of tan and secant, we have to remember, or we have to, the thing which it has to strike is 1 is nothing but secant square minus tan square. Let us write in the place of this numerator tan theta plus secant theta minus 1 can be written as secant square theta minus tan square theta. Let us keep the denominator as it is. Okay, is it clear? What it will become? Here it is tan theta plus secant theta will be as it is minus a square minus b square, that is secant square minus tan square, which is a plus b into a minus b. Is it clear? Whole divided by tan theta minus secant theta plus 1. Can we take tan theta plus secant theta common on from both the terms? Yes, we can. Let us take tan theta plus secant theta common from both the terms. What we will get? We will get 1 here minus this secant theta minus tan theta whole divided by tan theta minus secant theta plus 1, isn't it? Now, let us multiply to that side, that is tan theta plus secant theta into 1 minus secant theta minus into minus plus tan theta. If you observe here, this term and this term are similar, 1 minus secant theta minus secant theta plus tan theta plus tan theta. Can we cancel these both? Isn't it? What is left here? The left here is tan theta plus secant theta. What is tan theta? Sin theta by cos theta. What is secant theta? 1 by cos theta. If we take cos theta as LCM, we will get sin theta plus 1. This is nothing but our RHS. See here, we have started with LHS and we have got RHS. Therefore, hence proved. Is it clear? Did you understand? The problem is very simple, but make sure that you understand the basic concepts, right. What is that we have used a special thing from our previous classes is, instead of 1 we have substituted it as secant square minus tan square, right. Since we know that it is a square minus b square, we will write it as a plus b into a minus b, which is nothing but, if I take this secant plus tan as common, here I will get, since the whole term is removed, we will get 1 on the first term. From the second term I will get it as secant theta minus tan theta. Is it right? From this, if I multiply this minus inside, it becomes 1 minus secant theta plus tan theta. If we observe the numerator and the denominator, these both terms are same and they both get cancelled. The left out term is tan theta plus secant theta. What is tan theta? Sine by cos. And what is secant theta? 1 by cos. Is it clear? If we take cos as LCM, we will get it as sin theta plus 1, which is to be proved. Is it clear? Right? This is for today. From the next session, we will start a few simplification problems like this, and let us simplify few kinds of reduction things, which means few kinds of elimination angle. Okay? Is it clear? Thank you.